Hey everybody, Mr. Regan here, and we have another question in our simulator that deals with object A and B. Let's take a look. Which description best explains how the force exerted on the objects with the same mass change their velocity? So if you notice, we have object A and B starting at point A, ending at point B. Both objects have the same mass. And if you notice, object A and B have a start velocity of 0, and they have an end velocity of +5. So they went from 0 to 5. We need to decide which of these best explains how the force exerted on these objects changed their velocity. So let's take a look. Option 1, object A needs a larger force to have the same velocity as B. So we need more force on A. Option 2, object A needs a smaller force to have the same velocity as B. So A needs a smaller force. Or is it option 3? Object A needs the same force to have the same velocity as B. So take a second, decide which one makes the most sense, pause the video, and restart it to see the answer. All right, think you got it? Let's take a look. Both these objects have the same mass. They have the same start velocity. They have the same end velocity. So if we give A larger force, that means it would have a larger velocity than B. If A was given a smaller force than B, it would have a smaller velocity than B. Last but not least, A needs to have the same force to have the same velocity. We know this because a stronger force can cause a greater change in velocity. We know that A and B are the same mass, so if we give them a stronger force, they'll have a greater change in velocity. If we give them uh, a larger force gives you a larger change in velocity. A smaller force gives you a smaller change in velocity. So if we give them the same force, they'll have the same change in velocity. If we're going to run our simulator, here's our objects. They go from 0 to 5 as we see. If we were to run our simulator, the same force is needed for the same massed objects to get the same velocity change. That's our answer. Reach out if you have questions. Otherwise, good job.